All right, welcome back. So the last thing that we were talking about were the corners or the vertices of our feasible region, which I've highlighted here in yellow. And it turns out that in order to solve this problem, we actually need to figure out the ordered pairs or where these vertices or corners are located. And so a couple of them you could probably just tell from the graph, like this corner here, the bottom left corner is the point 0, comma 0. This corner here, when we graphed the blue line, we knew that that was our intercept. So that is 0, comma 48. And that 48 is coming from this 48 here. So hopefully you can see that that is that point. And then the last two corners, we're going to take a little bit more work to figure out what they are. So notice that the bottom right corner is where our red line crosses the horizontal axis. That is helpful because what we can do is we can set our W value equal to 0 in that equation, in the red inequality, to figure out um, the location of one of our corners. So let me just list out, so the vertices that we have so far are 0, comma 0, 0, comma 48, and our goal now is to try to figure out what the other two are. So for the bottom right corner, what we could do is we have this inequality here. I'm going to change it over to an equation. And notice at the bottom right corner, hopefully you see that the W coordinate is equal to 0. So we're just trying to figure out what the B value is. And sometimes you can't rely on your eyes, but if I'm relying on my eyes in this scenario, it looks like the B value is 20. However, I don't want to run the risk of relying on my ability to draw straight. So let's go ahead and plug in 0 for W to figure out what the B value is. So if I'm solving for B, I would subtract both sides by 80. So I have negative 80 is equal to negative 4b. And now I'm going to divide both sides by negative 4, and that yields b is equal to 20. Look at that. My eyes did not deceive me in that scenario. So our third vertex is 20, comma 0. However, our fourth and final vertex is not falling on a grid line, so I'm definitely not going to rely on my eyes to think about what that ordered pair is. Now notice if you're able to see the colors that that last vertex is where the red and the blue line cross. So that is useful because we can use or solve a system of equations because we have the equation of the blue line and we have the equation of the red line. Let me write those down here. And I'm going to use the slope-intercept form that we solved for. So W equals negative 2b plus 48. And then the equation of the red line would be W equals negative 4b plus 80. Now, to figure out the location of the fourth vertex, we just need to solve this system of equations. And there are numerous ways that you could do that. You could solve it by graphing. However, we kind of just did that and our eyes might deceive us, so I don't recommend using the graphing method. The other two methods that you're probably most likely to run into are the elimination method and the substitution method. I'm going to utilize the substitution method here, but again, those two are the elimination method and the substitution method. So if you want to do some more research into that, please feel free to do so. I'm going to use the substitution method today, which I think is going to be a little bit easier because they're both already solved for W. So I can just set them equal to each other and solve for B. So I have negative 2B plus 48. That is the blue equation. I'm going to set that equal to the red equation, which is negative 4B plus 80. And now I can solve that for B. So I'm going to add 4B to both sides. And I'm going to subtract 48 from both sides. And on the left-hand side, I will be left with 2B. And on the right-hand side, I will be left with 32. And then if I divide both sides by 2, I will get that B is equal to 16. So we know that the B coordinate of our fourth vertex is 16. How do we figure out the W coordinate? Well, if you said plug it back into one of the equations, Mr. Kwan, then you are absolutely right. Which one do we plug it into, though? Do we plug it into the blue one or do we plug it into the red one? Hopefully you said either one, Mr. Kwan, because then you would be correct. If we did this correctly, you could plug it into the blue equation or the red equation, and you should still get the same answer. So let's plug it. Blue's my favorite color, so I'm just going to plug it into the blue equation. So we have W equals negative 2. Instead of B, I'm going to write 16 plus 48. And then if we simplify that, we get negative 32 plus 48, which also equals 16. So I'm going to go ahead and plop that into my last vertex here. Okay, now I'm going to erase some of the work that I've done to make room. So hopefully you've copied this down. If not, you can always pause the video, but I'm going to erase a bunch of the work that I have here. Sorry that you had to witness that. That was kind of a hot mess. Okay, so we have our 4 vertices now, and hopefully you've been asking yourself, Mr. Kwan, we haven't really used the objective function so far, so let me just remind you what our objective function is. Our objective function, the thing that we are trying to maximize, is P is equal to 4B plus 3W. And it turns out that in every situation, like when we're doing linear programming like this, our solution that's going to give us the maximum or the minimum is going to be one of the ordered pairs that is a vertex or corner. So we have our 4 listed here, and now we just plug and chug and see which one gives us the highest profit. All right, so 0, 0, I'm going to plug that into my equation here, the one that I have boxed in green. So I have 4 times 0 plus 3 times 0. Hopefully it's no surprise to you that this is going to equal 0 and will definitely not give us any profit. So if I sold 0 burritos and 0 wraps, then my profits would be $0. Okay, now this next ordered pair is telling us, what if I sold 0 burritos and 48 wraps? Then I would make 4 times 0 plus 3 times 48, and that would be 144. I'm going to speed through this a little bit quicker. So if I sold 20 burritos and 0 wraps, that would give me a profit of $80. And the last combination of burritos and wraps would give me a profit of $112. So I think the question was basically asking, what combination of items do I need to sell that will meet the constraints but also maximize my profits? And we see here that the winning combination is this one. So maybe just to solidify understanding, we would say Mr. Kwan needs to sell 0 burritos and 48 wraps to maximize his profits and also meet his constraints. Now, if you were a business though, you'd have to probably think about like 100 other constraints. Like, for example, another thing that you would need to think about that might not even necessarily be a constraint, but how popular are wraps versus chicken burritos, you know? Like if I made 0 burritos and put all my eggs into these 48 feta wraps, am I going to be able to sell all of them? Well, in the context of this problem, it said that I always sell out whatever I make, but in reality, if I was a business, you know, wraps might not be as popular as chicken burritos, and so I would have to think about the demand as another thing. All right, see you later.